Okay, I've completed a position versus count table. And again, you see how you get the idea. 80 centimeters is right here. This is a little bit more than 80 centimeters, 82 centimeters. This one's a little less than 30 centimeters, 29.5 centimeters. Each one estimated from a rough scale I've got marked on the styrofoam here. Okay, so I want you to just look at this graph and see what you see. You should pause, take a good look at these numbers and see if they're behaving the way you would expect them to behave. See if they're behaving in a way that's consistent with the way these marks are spaced. See if I maybe made some errors in estimating the position. Okay, now hopefully you've given that a couple of minutes of thought and you've looked at these numbers. When you look at these numbers, if you want to see how these things are spaced, you're going to want to find the change in the position for each interval. Now that would be 2.5 centimeters. This would be 5 centimeters, 37 minus 32. This would be 5 centimeters. This would be 7 centimeters. This is 10 centimeters. This is 9 centimeters. And this is 14 centimeters. Okay? And clearly, you should understand these are just the spacings between the points. Now, are those numbers consistent with what you see down here? And are they consistent with what you'd expect? What would you expect for these numbers? Okay? And these numbers over here, of course, are the changes in the count. And this change is 3 because, remember, I started on 1. I really should have started my first count with 0, but I started it with 1. So the difference in the count is 3 quick counts. Now, the difference in every other interval, since I was counting in multiples of 8 and then in multiples of 4 between the multiples of 8, these differences are all going to be 4 counts, except for this one, which is 3 counts. Now, you should pause and think about those numbers and what they might be telling you. Having done so, I'm going to continue. Having allowed you to do so, I'm going to continue. I see a couple of anomalies. It really looks to me like each of these distances is at least a little bit greater than the one that precedes it. Okay, this distance is less than this distance. I've got my fingers blocking. Okay, this distance is a little less than this distance. This distance is just a little less than this distance, and this distance is clearly somewhat less than this distance. Now, given that I was marking these things and I have subconscious reaction to everything I do, that my measurements influence the way I measure, you don't expect this to be totally reliable, but at least, and I did this honestly, at least I do find that however slightly each distance is greater than the one before, and that's obviously what we would expect. Then I estimated these distances on a scale that, I don't know how well you can see this scale. You can't even see it right now where I've got the camera focused, but it's not the most accurate scale. Okay, so there's some anomalies with the scale I'm using. I could have laid a meter stick down here, as I said, and actually measured these, and maybe I'll do that, but I'm not going to do it on screen. Okay. We expect each distance to be greater. Well, what are these numbers here? These are the distances between the marks as I estimated the distances, and they aren't all consistent with what we expect. This one is the same as this one when we see clearly that this interval here, well, I'm not sure. That interval might be less than this interval, so we could have gotten 5 for both of those. So what I said a minute ago is each interval being greater than the other. Here at the beginning, it looks like we've got an interval here and an interval here where what I said might not even be true. We see the overall trend of the intervals is increasing, but here we have a 10 and here we have the 9. That could be that I just overestimated when I did this 59 and underestimated when I did this 68. If I just overestimated the 59, if that's really 58, then I'd get 9 and 10 here. I'm not going to fudge the data, though. I'm going to take the data as I honestly obtained it without trying to impose my expectations on it. Enough of my expectations were exposed in the process of taking this data. So now, from this data, we can calculate the average rate of change of the position with respect to the time. And that's just going to be delta y, change in position, divided by delta t, the change in time. Now the changes in time, well, here are our delta t's, the time between the subsequent estimates, and here are our delta y's in this column. So if we divide the delta y's by the delta t's, we get the average rates. You really ought to do that. Whether you will or not, I don't know, but I'm going to go ahead and do that off camera. Okay, I've done those divisions. I hope these are accurate. Rounded everything off to just the 10th because we don't have enough accuracy to justify any additional rounding. There's a little bit of a bias there because the 0.75s and the 0.25s all round up, and since we're dividing by 4, we get a lot of those. But still, it would be inappropriate to imply any more accuracy than what we've got here. We've already overestimated our accuracy. Okay, so we definitely see an upward trend, although there are a couple of little anomalies in there. What I want to do is I want to graph this average rate of change versus the count. The quandary is this average rate 0.8 involves the count between 1 and 4, the position between 29.5 and 32. So do I use the 1 or do I use the 4 along with the 0.8? And the answer is I don't use either one, I just average them. 1 and 4 averages out to 2.5. That's the midpoint of this first interval between here and here. It's a midpoint time. So I'm going to make a table of the midpoint time over here. And I'm going to do that off camera because you don't need to watch me do that. You should understand, and you should do the same thing. What's the midpoint of each of these time intervals? What's mid between 4 and 8? What's mid between 8 and 12? So between 4 and 8, we got the distance of 5, the average of 1.3. That would go with the midpoint of this time for reasons that you should think about a little bit. Okay, I've done that. I've got these midpoint times. You can check them with yours. For example, the midpoint between 20 and 24 is 22. Midpoint between 24 and 28 is 26. Now this velocity, we don't know that it occurred right at the midpoint of the times, but that's much more accurate than using either the beginning time, say 24, or the ending time 28. The 3.5 it was the average rate of change between here and here. So if we're going to pick one time to associate with that average rate of change, it'll be the midpoint, T mid, which is 22. That's a midpoint. And similar midpoint on all these down here. I'm not going to label all those. Okay, so I'm going to do a graph. And I'm going to label off my time from 0 to 22 and my average rate of change from 0 to 4. And then I'm going to fill in my points, but I'm not going to make you watch me do that. You should do the same.